Alright everybody, I wanted to kind of go over how to attack this take-home quiz and all these problems. So notice I have enabled you to fast forward through this worksheet so you can just see the ones that you missed so you have a better understanding. So I'm going to go through the whole thing. You don't have to watch the whole thing, just kind of make sure that you understand each problem that you missed, because we don't have a quiz for a while. So I wanted to make sure that before we move on and do more harder stuff that you're familiar with how to do these. Okay. So very first problem here says state the domain of the function. So look at our x value, our farthest value to the left, this x value is -8. And then it travels along, and even though it's an open circle here, it's closed here, so it continues. And then once you hit this x value of -3, where's the next x value on the graph? It's not until -1. So we have this huge gap in here of no x values in between -3 and -1. So the first section of my domain, the farthest point to the left is -8, and it is continuous until you hit -3, and then it stops. So that's the first part of my domain. It goes from -8 to -3, and notice how I put a parenthesis on -3 because that point at -3 is not filled in. And then again, it starts again at 1. It is not continuous between -3 and -1. There's a huge gap there. There's not a gap here because one circle is open and one circle is closed. So this x value of -5 is used right here, and then it continues until -3. So there's my first section of the domain. And then my second section, where does the graph start again? It starts at -1. with an open circle, and it is continuous until x equals 6. So -1 with an open circle, and then 6 with a bracket. So there is the entire domain of the function. So when you look at this function, at this domain, you see that there actually is a gap between -3 and -1. And that gap is represented right here. We do not have any part of the graph in between -3 and -1. So I can't say that the domain goes from -8 to 6 because it's jumping over everything in between -3 and -1. So for the range, we're going to kind of do the same type of thing. We have values down here at y equals -5, so that's my lowest point. Even though it's open here, it's closed all here, it's closed there, and it's closed there. So lowest point is -5. And then it goes up until what? The highest y value here is -1, and then notice how again I have a big gap in here where there's no graph at all. So I need to stop it at -1 and then pick it up again at y equals 0 with a parenthesis, and then it goes as high as y equals 4. Okay, so when it's different sections like this, it's a little bit harder to see, but my first section goes from -5 until -1, and it stops here at -1. So that's going to be my first section. And then I have this gap in between 0 and -1. So I can't say it's continuous up until 0. It actually stops at 1, and then it picks up again at 0 and goes as high as 4. And the 0 is an open circle, that's why I'm using a parenthesis, and the 4 is not an open circle, so it gets a bracket. So those are just the y values. So a lot of you on the worksheet had -8 to 6, but you have to skip this section in here because there's a big gap there. Okay, and then same thing, a lot of you had -5 until 4, which you're almost right, but there's a gap right here for the y value, so you have to skip from -1 to 0. Okay, now let's do where the function is increasing. So if I had highlighters, I would highlight this part right here, and those x values occur between -8 and -7, so that's my first increasing part. I have another increasing part right here. Those x values are 2 and 4. And remember, increasing, decreasing constant is always x values only. So -2 and 4. Or +2 and 4, excuse me. Those are my two increasing sections. And then notice that I actually have 3 decreasing sections. One here, and one here. So my first decreasing section is right here. Those x values are -7 to -5. -5 is an open circle, so I'm putting a parenthesis there. My next decreasing section is from -5 to -3. -5 with a bracket, -3 with a parenthesis, and I actually have another section of decreasing, which is right here. Those x values are 4 to 6. And then a couple of you asked me, since the -5 is open here and closed here, yes, you can write this section as one category. You can do -7 to -3 because there is no gap here. The -5 is not used here, but it is used here. So you could write this as -7 up until -3. You can combine those or you can separate, I don't care. All right, now let's do where is it constant. So constant means flat. We have one flat section right here. The x values here are -1 up until 2. It is flat between -1 and 2. It's an open circle on -1. It is a closed circle on 2. So there's one constant section. And remember, for these three, for increasing, decreasing, constant, you're always giving the x values. Okay, it's a little bit confusing because you're kind of looking at the y values when you're deciding increasing or decreasing or constant, but you're giving me the x values where that happens. So now it says find f of -5. Remember, that means when x is -5, you're trying to tell me what the y value is. So I'm going to find on the graph when x equals -5. That's right here. The y value of 0 is an open circle, but the y value of -2 is a closed circle. So I'm using the -2. And now it says find where f of -2 is. That means when x is -2, what's the y value? Well, here's when x equals -2, and I do not have a y value for the x value of -2. There's no graph at x equals -2, so that means that there is none. Don't say 0, because that would mean there was a point actually at 0. So don't say 0. It's either none or it's not in domain. And then the last one is f of 3. So that means when x equals 3, which here's where x equals 3, all along here, boom, my y value right there is -3. So I kind of like to trace my finger along the x value of 3 and figure out where it hits the graph. The y value there is -3. Okay. And then a couple of us got confused on this like x value, y value situation. So what I like to kind of think about in terms of, you know how f of x is just a fancy y. So what we're doing here is it's asking when y equals -3, what are the x values? So this is kind of the opposite of what we just did in number 6, 7, and 8. So what I like to do actually is go to my graph and draw a line at y equals -3. And I drew this on a lot of your worksheets for those of you that missed this one. When you draw the line y equals -3, where does it touch the graph? It touches the graph here, here, and here. So we actually have 3 answers. And so when y equals -3, it's asking me for the x value. So the x value here is -4, the x value here is 3, and the x value here is 5. So I have 3 different answers: -4, 3, 5. Okay, I'm actually going to do the same thing at the y value of +3. So I'm actually going to go to +3. I'm going to draw that line. This line up here is y equals 3. And it's asking me for the x values where it touches the graph. So it touches right here, closed circle, and it also touches right here. So it touches my graph in 2 different places, and I need to give those x values. So here is -8. Here is, what is that, -6. So those 2 x values are where the y equals 3. So I have -8, -6. Okay? This is probably the most commonly missed section, is this graph, and I will definitely agree with you guys. That is a weird, funky looking graph. But I explained very slowly how to do like each of those parts, so hopefully that makes a little bit more sense, and this is definitely a complicated graph. If you understand this section, you should be definitely good on anything I could give you on a quiz or a test. So let's go to number 11. Some of us had some issues with writing the equations of lines. So what I want to talk about first is, this says write the equation of the line through a point perpendicular to this line. So what you should be thinking to yourself is, if it has to be perpendicular to this, then I need to know what the slope of that line is. So that's what I did first, is I'm going to zoom in on this line and I'm going to try and figure out what the slope is. Move the 2x over, divide everything by 3, the slope of this line is negative 2/3. That means the perpendicular slope is positive 3/2, and that is what I'm going to use when I write my equation. So that's step one, figure out the slope. If it was parallel, then I would use this slope. But since it said perpendicular, I have to do the opposite reciprocal. So that's the slope that I'm going to use. And they also gave me this point, 3, -4. So that means I'm going to start with point slope form because I'm given a point and a slope. And that's the first thing that I have to write my answer in, is point slope form. So when I write point slope form, remember you do y minus the y value, which yes, that's a double negative, and yes, I'll change that to a positive, equals the slope, which is 3/2, x minus the x value. And again, the x value is this 3. So all I have to do is change that double negative, 3/2 x minus 3. This is point slope form. You do not distribute, you do not combine like terms, that is your point slope form. So here's where a lot of us had some issues though, is that I also asked for standard form. A lot of you gave me y-intercept form, which just means distribute all this, minus your 4 over and you're done. That's slope-intercept form. You guys need to know the difference. So here, it's asking for standard form. So what I am going to do first is distribute. So that's y plus 4 equals 3/2x minus 9/2. When you distribute the 3/2 to -3, a lot of you cancel the 3's. Dude, it's 3 times -3 and 2 times 1. It's actually -9/2. So be careful. And then you know that what we're doing for standard form is that you can't have fractions. So before I start combining like terms, let's make it a little bit easier on yourself. And let's multiply everything by 2 to cancel the fractions right away. That's going to give me 2y plus 8 equals 3x minus 9. Now I'm almost there. I've gotten rid of all of my fractions, and then remember for standard form the x has to be positive. So I'm going to leave the 3x where it is, move over the 2y, and I'm going to add the 9 over to this side. That's going to give me 17. There is my standard form, you guys. 3 things for standard form. Number 1, x and y on both sides, on the same side, the number on the other. Number 2, no fractions. Number 3, x has to be positive. 3 things for standard form. That is how you work through number 11. Okay. Number 12, write the equation of the line through this point parallel to this guy. Well, you need to know what this looks like. This is a horizontal line at -2. That is what y equals -2 looks like. So if it's parallel to that, the slope is still 0. A lot of you, I think, thought that -2 was your slope, but no. Remember, if you're running on a treadmill and it's completely flat, you have set the incline to 0. There is no slope. So I need another line that has no slope. So where is the point -5, 7? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Boom. The line that's parallel to y equals -2 has to go through this point. So basically just bring this line up here. And if it's parallel, that means it is another y equals line. It has 0 slope. 0 slope. But it has to go through this point. So what is the y value up there? It's 7. Done. Next question. What if I said perpendicular? If I said perpendicular to this line, then it would be an x equals line, and it would be x equals, what's that x value? -5. Okay, so not much thinking, not much math. There is 0 slope here, and some of you tried to use like slope-intercept form and stuff. That's fine, but when it's flat like this, you have 0 slope. So you should plug in a 0 for your m for that one. All right, next section, determining whether it's a function. So again, if you do vertical line test for this, it's just a straight line. It does not have any vertical line test issues, so yes, it is a function. Domain and range. Does it go left forever? Yes, because of the arrow. Does it go right forever? No. Where does it stop? At x equals 4. Okay, x values for domain. The farthest to the right point on this is x equals 4. So -infinity up until 4, bracket because it's a closed circle on 4. Okay, for range, does it go down forever? Yes. Does it go up forever? No. it stops, the highest point that I have here is 6. The y value here is 6, and the range is always the y values. So negative infinity up until 6 with a bracket. There's our domain and range for that one. Number 14, absolutely not. This is not a function. You can draw a vertical line in a bunch of places on this graph and get it to touch twice, which means no, it's not a function. The domain is all the x values in between negative 3 and 6. Some of you asked me about it. I got it as close to 6 as I could, but since it's not even, you can assume that it's 6. My bad on that. It should go all the way to 6, but I couldn't get it all the way there. The range. The y values go between negative 3 and 4. So again, it's kind of like cropping this one. Negative 3 and 4, not a function. All right, last one, vertical line test. The only time that we might have a problem with vertical line test is right here, but that's open and that's closed. So yes, it is a function. It passes the vertical line test. The domain, this arrow indicates it goes left forever. I do not have a gap anywhere because this is closed, this is open, and it goes to the right forever. So my domain, negative infinity to infinity. And then the range, let's see, I definitely go up forever, and this section is in there. So it starts at negative 6 and goes up forever. It does not go down forever. The lowest point here is negative 6. So the way I write that is negative 6 with a bracket because it's a closed circle, and it goes up forever, even past this. So infinity. All right, now last section. Let's see, the following piecewise function, you guys should have an idea of what these look like. This is a y equals mx plus b situation. This is a parabola. And we have two different domain restrictions. So if I'm going to do my t-charts, zoom in a little bit. I'll do a blue one and a red one. So my blue one first, and I'm starting at 3 and picking numbers bigger than that, and continuing. Open circle on 3. When I plug in 3 to this equation, I get 5. Plug in 4, I get 7. Plug in 5, I get 9. Let me see what that looks like over on my graph. Let's see, zoom out a little bit. 3, 5 with an open circle, and 4, 7, 5, 9, and it continues in that direction, so arrow to the right. Do not put an arrow to the left because I have a stopping point there. It's an open circle at 3, 5. Now let me do my red t-chart. So let's see, starting at 3, closed circle, and it's telling me to pick numbers less than 3, so 2 and 1. When I plug in 3, I get 8. Plug in 2, I get 3. Plug in 1, I get 0. Let's see what this looks like on the graph. 3, 8 is up here. End point. Do not put an arrow to the right because that's my starting point, and I'm only picking x values to the left of that. 2, 3 is here. 1, 0 is here. If I connect, does this look like a parabola? No, so I'm going to pick a couple more just to be a little bit more accurate. What happens if I plug in 0? When I plug in 0 to this, I get negative 1. What happens if I plug in negative 1? Negative 1 squared is 1, minus 1 is 0. Let's see if those two help me get a more accurate shape of my graph. 0, negative 1 is here. Negative 1, 0 is here. Okay, now I'm starting to come back up. Now it looks like a parabola, and it goes that direction with an arrow. Your t-chart continues. You keep picking points for the x value, and if you pick more points than 3, if you're ever unsure about what the graph is supposed to look like, it'll just be more accurate. You have to have at least 3 points per section per the directions, and that's how it'll be on quizzes and tests. But if you're unsure about what the graph's supposed to end up looking like, or if you know this is a parabola and it doesn't look like one, then pick more points just to be more accurate. Okay, so now 17 says find f of negative 5. Well, the x value of negative 5 is here. That's not on my graph. So I'm just going to take the easy way and take this negative 5. It's less than 3, so I plug it into this equation. Negative 5 goes right there. So when I square negative 5, I get 25 minus 1 is 24. And then what about the 6? The 6 is not quite on my graph. It's way up here somewhere. I don't really want to guess. So, where does the negative 6 fit into? Or positive 6? 6 is bigger than 3, so I'm plugging in right there. 2 times 6 is 12, minus 1 is 11. Remember, you can look at the graph or you can use the equation. All right? Let's see, a couple more. Write the equation of the piecewise function. You can see that we have two categories, this one and this one. So I'm going to set f of x equal to, here we go. So let's first talk about the x values. Let's do this piece first. So this piece has an x value of negative 1, and it goes to the right forever. So for that, I am going to say if x is greater than or equal to negative 1. My other section, this x value is at negative 1 to the left forever. So less than negative 1. And those two, like, you can reverse these two. It doesn't matter the order as long as you have, like, both parts of the graph. That part doesn't matter. So this flat line, this is the easier part. You're just looking at that equation and trying to figure out, or that graph, and trying to figure out what the equation is. That is a horizontal line, which is a y equals line, and the y value there is negative 5. So that's where I'm getting negative 5. So no matter what x value you plug in, you get a y value of negative 5 in this category. So those go together. Now all I need to do is figure out the equation of this line. So you guys need to be able to look at a graph of a line and tell me what the equation is. So if I zoom way in here on this line, it doesn't touch the y-intercept, or it doesn't touch, the y-axis yet, but I'm pretty sure we can figure out at least what the slope is. So like here's a point on the line, here's a point on the line, here's a point on the line. So what is the slope? You're going up 2 over 1, up 2 over 1. So that means that my slope is 2. And what's my y-intercept, my b? So I can't really tell, but if I continue with my slope, up 2 over 1, up 2 over 1, up 2 over 1, pretty sure I can tell what the y-intercept is. It's right there, it's at 5. So do you know how to write the equation of a line with the slope of 2 and the y-intercept of 5? All that is, I guess I could write it on here if I wanted to, y equals 2x plus 5. So that's where I am getting this. Y equals 2x plus 5. And that's because the slope is 2. Y-intercept, you have to continue the line sometimes to be able to see it exactly. Y-intercept is 5. That's where I got that. A lot of you did that one right. I'm really proud of you. So good job for that. Let's do the last one. Sketch the shapes of the graph below. Try and do it without looking at your notes. Well, by now you guys should for sure be able to know what these shapes are of these graphs. Y equals x, line, straight line. Y equals x squared, parabola. Y equals x to the third, snake, getting really high really fast. Absolute value, V shape. Square root graph, that, my friends, is the sprinkler, only goes in one direction. The cube root is very similar to the cube, except it's sideways. And this is supposed to be the step function. My bad about that symbol. Remember, close circle, open, close circle, open, close circle, open, and it continues forever, and they look like steps. Okay? So that, hopefully you've got that. A couple of you are a little bit off on some of your shapes, but for the most part you got those in your notes, and we've been talking about them for a long time, so hopefully you've got those formulas kind of memorized. Alright, that's it. If you still have questions, you're still confused about stuff, hopefully it's starting to sink in little by little. Pretty tough, challenging chapter of all brand new material here, but you guys stick with it. You know where to find me if you need help, and hopefully you're getting more and more prepared for the quiz coming up, okay?